Well, good afternoon. This is our lesson for Tuesday, March 17th. We're going to start Chapter 7, as I mentioned last week, and Chapter 7 is on solving systems. Just kind of want to give you a rundown for the week. We are going to work on solving systems by substitution today. On Wednesday, we're going to work on solving by elimination. Thursday, we're going to work on word problems, and by Friday, I'm going to figure out how to give you a quiz online. Be sure and send me your questions as you're working through the assignments that I'm going to give you. Make sure and try and get them to me before 10 o'clock each day so that I can work on them during our 10 to 10:30 session. If you can't get it to me before then, I'll still work them and get them to you by email. You need to have your books open to page 452. And as you can see, we have listed the 6 different ways that we are going to solve systems in this chapter. And remember that a system of equations is 2 or more equations with the same variables. And you are looking for the solution to the system, and that would be the values that you substitute for the variable that make all the equations true. In Algebra 1 and Geometry, you work on substitution, elimination, and graphing. And then we're going to review those. Then we'll move into using matrices to solve. And you see the Gaussian elimination, the matrices, and the Cramer's rule. In the blue box on page 452, you'll see the method of substitution. And if you read through that, it sounds kind of complicated. Hopefully, as I go through this example, you will remember how to do these. We are no longer in trig. It's just going to be some basic algebra for a little bit. So we have the system 2x plus 3y equals 7 and 6x minus y equals 1. These are linear equations. We are looking for the x and y that make both equations true at the same time. We need to isolate one of the variables, the x or the y. The best choice is to pick the variable that doesn't have a coefficient in front. So I'm going to take the bottom equation, 6x minus y equals 1, over to the side, and I'm going to solve for y. So I would begin by subtracting the 6x over, and then I'm going to divide by -1. And so I have y equals -1 plus 6x. And then we're going to take this expression for y and substitute it into the top equation, because again, these x and y are going to be the same value. I'm going to use parentheses, and I'm going to substitute in place of the y -1 plus 6x. Now I have an equation all in terms of x, and so to solve this, I'm going to distribute the 3. So I'm going to have -3 plus 18x equals 7. I'm going to combine my like terms and add the 3 over and divide by 20 and reduce to 1/2. So my x value is 1/2. Don't forget to go back and substitute into your other equation and solve for the y value. And 1/2 of 6 is 3. And so y is going to equal 2. So the point 1/2, 2 is the solution point to the system. That means that it is the point of intersection if we were to graph. It is the solution that makes both of these equations true at the same time. And let me show you that. If I take the 1/2 and the 2 and substitute it into the top equation, 1/2 of 2 is 1, and 1 plus 6 is 7. So we have a true statement in our top equation. If I do the same and enter 1/2 for x and 2 for y in the bottom equation, 1/2 of 6 is 3, 3 minus 2 is 1, and I also end up with a true statement. So 1/2 and 2 would make up the solution to the system, this equation system right here, system of equation. All right, I would like for you to turn to page 460, and I want you to try number 16. So pause the video and give this problem a try. So the directions are solve the system by the method of substitution. We have x plus 2y equals 1, and 5x minus 4y is equal to negative 23. We have choices on what variable we want to solve for. Again, I could solve for any one of these, but I'm going to pick the variable, the equation with the variable that doesn't have a coefficient, just so I can avoid the fractions as long as possible. So I'm going to have x is equal to 1 minus 2y. I'm going to take that expression and plug it into the second equation in place of x. Now I have an equation all in terms of y. I'm going to distribute the 5. I'm going to combine my like terms. I'm going to subtract the 5. I'm going to divide by negative 14, and I get y is equal to 2. I'm going to take the 2 back up to my first equation, and I'm going to figure out that x is equal to negative 3. So the point negative 3, 2 is the solution to the system. If we were to graph these two equations, it is where they would intersect. Now I would also want to talk about number 22. Number 22, we have a lot of fractions. 1/2 x plus 3/4 y equals 10, and 3/4 x minus y is equal to 4. Now we've talked often in our trig about getting rid of little fractions inside of big fractions. The same method of multiplying by the common denominator can also clean up our equations a little bit. We need to solve one of these equations for y. I'm going to pick this one, but I want to clean this one up a little bit. Fractions are our friends, but they tend to lead us astray sometimes. So I'm going to multiply this top equation, everything in it, by 4. And so if I distribute, half of 4 is 2. So I have 2x. 3/4 times 4 would leave 3y. And don't forget to multiply the 4 and the 10 together. So that equation just looks a whole lot better. Now this one, if I did that, I would be moving the 4 around, but then when I go to solve for a variable, I'm going to introduce fractions again. So I'm just going to kind of live with it, and I'm going to get the y by itself. So I'm going to subtract the 3/4 x over to the other side, and I'm going to divide everybody by negative 1. So I have y is equal to negative 4 plus 3/4 x. So I'm going to take that up here, and in place of the y, I'm going to put negative 4 plus 3/4 x equals 40. I'm going to distribute the 3, so I'm going to have negative 12 plus 9/4 x equals 40. I'm going to add the 12 over to the other side and get 52. I'm going to combine 2x and 9/4 and get 17/4, and your calculator will do that for you. I'm going to multiply by the reciprocal, which is the same as dividing. And when I do that, I get this lovely answer of 208 over 17. Now in Algebra 1 and Algebra 2, you would never have an answer like that, but in Precal, they don't really care about your self-confidence, and they are going to give you some answers that make you wonder if you are doing it correct. And we are. And we're going to take this 208 over 17 and substitute it into the other equation. And when we solve, we're going to end up with y is equal to 88 over 17. So again, not a very good confidence builder, but it is the correct solution to this equation. Now, real quick, I'd like to look at one more. Number 34. We have negative x plus y is equal to 3. X squared plus y squared minus 6x minus 27 is equal to 0. So the other examples that we've been looking at are two linear equations. And that's what you would have done in Algebra 1 and in Algebra 2. Here we have a linear and a circle. And so a line and a circle will probably intersect at two places. And notice that we have some squareds here, so we're going to have some quadratics. I'm going to start the same way. I'm going to take the top equation and solve for y. So I'm going to have 3 plus x. I'm going to substitute that into the bottom equation. In place of the y, I'm going to put 3 plus x. I need to make sure I've got my parentheses and my exponent. You guys know that I would probably be asking questions as we go through this. And my question would be, how do you square a binomial? And hopefully you would say that you FOIL. And you would get 9 plus 6x plus x squared. So we have a quadratic. And so to solve a quadratic, we need to combine all of our like terms and have the equation equal to 0. The 6x's are going to cancel out. X squared plus x squared is 2x squared, and 9 minus 27 is a negative 18. I'm going to take out a 2, and that leaves x squared minus 9. I'm going to factor into x minus 3 and x plus 3. So I'm getting two x's. I've got x equals 3 and x equals negative 3. So when I go back up to my y and I put in positive 3, I get 6. When I put in negative 3, I get 0. So this line and circle intersect at two places. We have the point 3, 6, and we have the point negative 3, 0. Now, if you were looking at the directions for this problem, it actually said to solve the system graphically and verify algebraically. So we did the algebraic method first. So I want us to talk about graphically. So if we have negative x plus y equals 3, and x squared plus y squared minus 6x minus 27 equals 0, and we want to solve graphically using our calculator, we would need to first of all solve for y, which we already had. This one was y equals 3 plus x. Now this is a circle. We want to solve for y. So we're going to subtract over the x squared, add the 6x, and add the 27. Now to get rid of a squared, we're going to square a root. And we talked about this at the beginning of the year. You are going to need a plus or minus in front of the square root. And what you're going to have to do to put this into your equation, in y1, you're going to need the positive version of the square root. And in y2, we're going to put the negative version of the square root. So get your graphing calculators. And can't see that very well. We'll see if it'll work well enough. Let me get it typed in. I'm going to put the square root of negative x squared plus 6x plus 27 as y1. Then I'm going to have the negative square root of x squared plus 6x plus 27 for y2. And for y3, I'm going to put the linear 3 plus x, and we hit graph. And notice that it does not look correct. Okay. So I'm going to go back to my y equals my second equation. I forgot the negative underneath, so I'm going to insert the negative and regraph. There we have our top equation, the bottom of the circle, and our linear. And again, we talked about this at the beginning of the year. The calculator, these would actually touch, and that would be our point -30, which we found. This was our 0.36. We can type zoom square, and that will make it look like a circle instead of an ellipse. And you can look at the table, and you can see that they have the 3, 6, -6, and 6. And if I type in -3, you'll see that there's 0 there as well. So you can double check with graphing. Mainly interested in the algebra approach, but you will have a few that you can check with your calculator. All right, I'm going to go ahead and put your homework assignment right here, but I will also put it in Schoology. This assignment needs to be done by tomorrow, and I'll type it in to Schoology so you'll know exactly when. Notice that I'm giving you the odd answers because I do care about your confidence, and I want you to be able to check those ugly fractions and see if you have done it correctly. Be sure and email me your questions, and I'm going to work on seeing if we can do some Zoom or some type of FaceTime, something like that, where we can actually talk rather than have to type our questions and answers. So get your homework done, and this is going to have a due date of tomorrow. Remember that doing your homework and turning it in is how we're going to count attendance. So I'm not waiting until Friday. This will be due probably Wednesday, but I'll get that typed in for you. Let me know your questions.